Next, we want to approximate with what's called a midpoint rule. So we use a capital M for midpoint. N is your number of rectangles again. And with midpoint rule, let me show you the demonstration here first. So we had our left-hand rule, get the heights of the rectangles from the left side. Right side, you get your heights of rectangles here going up from the 4 right endpoints. The midpoint rule, you use the middle of the interval and go up to the graph of the function to get your height of rectangles. And each rectangle has some overshoot and undershoot. So this approximation actually ends up being one of the better approximations. You can see with just 4 rectangles, we got 1.43 in the exact 416. So what happens if we do that here with n equals 2? So remember n equals 2. Then we've got our height times base for our first rectangle, and that x1 bar is the midpoint of the first subinterval. So if n equals 2, our delta x is still going to be 1 minus 0 over 2, which is 0.5. So same delta x. So our first interval 0 to 0.5, that midpoint is at 0.25. And our second interval is 0.5 to 1. The midpoint is at 0.75. So we're going to go up from that midpoint here to get the height of the rectangle. So right there is going to be height of our first rectangle. And then here, height of our second rectangle. So those rectangles are going to look something like this. So to get my height, I'm looking above the 0.25, so about right there. So I'm looking up from here. And then the second rectangle, I want my height from above the 0.75. So that rectangle would look about like that. So again, I'm looking above the 0.75, function value at 0.75 to get my height. So then we can estimate the integral from 0 to 1, e to the negative x squared. We can have that 0.5 on the outside. That's my delta x. And then my first height of this rectangle, well, it's 0.75. So let's see, 0.8. This looks like this might be about 0.95. Just estimating. And then the height here, we go across, I'd say maybe about 0.6. So that's graphically. And then if we want numerically, 0 to 1, e to the negative x squared dx, 0.5. And then we're doing the function value at 0.25 here to get our height. And then here the function value at 0.75. So f at 0.25 plus the second height f at 0.75. So that'll be 0.5. Plug 0.25 into the function, e to negative of 0.25 squared. And then here plug 0.75 into the function, e to the negative of 0.75 squared. So let's compute those on the calculator. I'm going to do the second one first because I've got this up in the display. I'm just going to press second enter. That will let me go back in here and edit. So for the 0.5, I want to change that to a 0.25 right here. So I'm just going to do a second insert and insert a 2. And then I'll arrow over here. I'm going to go ahead and delete that 1. And I'm going to do a 0.75. And there we have it. Enter. So 75459, 7546. And then our estimate up here is going to be rougher estimate. So let's go ahead and do that one, 0.5. And then it was 0.95 plus 0.6. Close that parenthesis. Oh, there should be a plus, not a times. Plus 0.6. There we go. And about 0.775. So your numerical estimate almost always be better than your graphical estimate. So that's the midpoint rule.